Hey everyone, let's take a look at assignment 60. This is the partial fraction decomposition summary worksheet. Well, I see there are only 12 problems for us to take a look at. And again, I want to say that, I wouldn't do this worksheet unless I'd watched the partial fraction decomposition videos already. This video is for people who have done that practice and engaged in that work. Okay, number one. First, you want to use magic numbers or systems to solve for the coefficients in the partial fraction decomposition below. Well, that's a great question. Ooh, and then why? And we're asked to do this problem two ways, once by systems, once by magic numbers, to see what we think about our choice. Okay, and so the problem is 2x squared minus 4x plus 1 over x to the third minus 3x plus 2. And the breakdown on the other side is a over x minus 1 plus b over x minus 1 squared plus c over x plus 2. All right, and so presumably this is that times that. So, I don't know, what do you think? Just, if you have no idea, guess one of them. All right, so I'm going to say we have 3 letters, and I have 2 different magic numbers. I think I'm going to do magic numbers and a not so magic number. So I'm going to multiply both sides by x minus 1 squared times x plus 2. X minus 1 squared times x plus 2. X minus 1 squared, x plus 2. And x minus 1 squared, x plus 2. Again, I really do write it out because I'm tired of making those mistakes. You don't have to write it out. When you make that mistake, don't come sad to me. All right, so now I've got on the left-hand side that same 2x squared minus 4x plus 1. And over here, one of those cancels, so I have a, x minus 1, x plus 2, plus b. This takes all of those, so I just have the b times x plus 2. And here this takes that, and so we just have c times the x minus 1 squared. So I had suggested that I would prefer to use magic numbers here, I think, because look at all that foiling. If x equals 1, that'll disappear, that'll disappear. I'll have 1 plus 2 is 3b. And on the other side, 2 minus 4 is negative 2, plus 1 is negative 1. So b is negative 1/3. And my other magic number, x equals negative 2, will make this disappear, will make this disappear, and so now I'm over here. Minus 2 minus 1 is minus 3. Minus 3 squared is 9c. Now what happens if we plug that negative 2 in here? Negative 2 times negative 2 is 4. 4 times 2 is 8. Negative 2 times negative 4 is also 8, so now I'm up to 16 plus 1 is 17. And so c is 17 ninths. Now I see ninths here, and yeah, I'm going to turn this into minus 3 ninths. Because I wonder if that will be easier as I go along. I've used 1, I've used negative 2. I think 0 could work. I think also 2 could work nicely. Let's go with 0. I think that's what most students would do as a not-so-magic number. If I plug in a 0 over here, I get 1. If I plug in a 0 here, I get negative 2a plus 2b. And I plugged in a 0 here, so I'm just getting a c. All right, and we know what b and c are, so 1 equals negative 2a plus 2 times negative 3 ninths plus 17 ninths. Well, that's going to be minus 6 ninths plus 17 ninths. That's going to be 11 ninths equals 1. And 1 is 9 ninths. So if I subtract 11 ninths from both sides, I'm now going to have negative 2 ninths. If I divide both sides by -2, I find that a is -1/9. All right, so I got my values. I feel pretty comfortable with that. We would have -1/9 over x minus 1 plus, minus 3/9 over x minus 1 squared, and then finally plus 17/9 over x plus 2. There's our partial fraction decomposition. By the way, these problems take a lot longer if you complain. So don't waste your time complaining. Just get it done. Stay focused. Like so many things you don't want to do in life, this advice will help you tremendously. 2x squared minus 4x plus 1. And I had thought to do some systems here, right? The problem says try it both ways and see if you were right. So I'm going to have a x squared plus x minus 2 plus bx plus 2b plus c x squared minus 2x plus 1. I still have to do some distributing here and distributing here. Ax squared plus ax minus 2a plus bx plus 2b plus cx squared minus 2cx plus c. Whew. Okay, so I grouped the stuff with x squareds together. 2 equals a plus c. And I grouped the stuff with x to the first things together. Yeah, so now I'm going to have -4 equals a plus b minus 2c. And finally, the things that have no x's attached to them. And that's going to be 1 equals -2a plus 2b minus 2c. Oh, no, not that. No, it's just the c here, and that's a positive c. Okay, I was taking that cx term. I should know that. Well, yeah, that sucks. I don't have any idea what any of the variables are, and I'm literally going to have to solve this three equation, 3 unknown system in order to solve this. So I don't need to go any further to know that magic numbers and one not so magic number would be the best shot for me. Okay. I mean, you're welcome to solve this 3 variable systems, but I'm saving that for when we do the systems unit in December. Okay, number 2. How would the setups for these 3 be different? All right, so part A, I've got 1 over x squared minus 1, which is the same as 1 over x minus 1, x plus 1. And so my setup would be a over x plus 1 and b over x minus 1. That's non-repeated linear factors. That's case 1. This one, however, that's case 3. That's an irreducible quadratic. If I try and factor that as a difference of squares, I'm only going to have imaginary roots show up, and I don't want that. So I'm going with ax plus b, x squared plus 1. Remember, when we have these irreducible quadratics, the top has to be 1 degree less than the bottom. And for those of you who say, why isn't it just this? Well, this ax thing makes a linear equation that goes through the origin. Tell me, in your life, have you ever graphed a linear equation that, I don't know, didn't pass through the origin? In fact, most of them do. And so we don't know if this is going to be one of those magical ones that passes through the origin, or if it was shifted up or down some. So we have to allow for that possibility. And then finally, C looks a lot like a case 2 problem where we have a repeated linear factor. And so we have a over x minus 1 and b over x minus 1 squared. Okay? Show each setup as part of your explanation. Well, you heard me explaining. Here are my setups. I'm moving on. Now the next bunch of problems, is it 9 problems, 8 problems, are, or 10 problems, it's 10 problems, are just partial fraction decomposition opportunities. And so we've got 4 over x minus 1, excellent. So that's going to be a over x plus b over x minus 1. When I multiply everywhere by the least common denominator, this here, I've got lots of canceling. And so now we've got 4 equals a x minus 1 plus bx. Okay, so if I make x equal to 1, this disappears. There's no place to plug a 1 in over here, and I can plug the 1 in here and just get b. So when x is equal to 1, this goes away, b equals 4. And that's very nice. If I make x equal to 0, this goes away. 0 minus 1 is negative 1 times a, and no place to plug a 0 there. So I know a is negative 4. My decomposition then would look like that. There's my answer. Okay. You know, I kind of like sometimes this mode of learning where I do the instruction and then you watch it when and as often as you have time and need. But I hate not getting to ask you questions at this point, and I hate that you're not really taking advantage of the opportunity to ask questions at this point. So, you know, things, yeah. In the times of COVID, we must be flexible. Number 4, we've got x squared minus 3x plus 2. We know that denominator is going to factor as x minus 2, x minus 1. If you're not comfortable with your factoring yet, you might want to take some time and go back and practice that. That makes these problems much, much easier. And so I'm going to have a over x minus 2 and b over x plus 1. Of course, these could be flipped. Doesn't matter. I mean, if we flip them, this person's a value will be that other person's b value. But it'll look the same at the end. If we now multiply everywhere by our least common denominator, x minus 2, x minus 1, we can get some canceling going here. We know that these cancel these, and we're left with x, this, and this, leaving us with, that's a minus there, Mr. Goodflow, what doing? So that canceled that, so on the other side I have a x minus 1 plus b, this cancels this, times x minus 2. Okay, this is a classic case 1, definitely using magic numbers here. When x equals 1, I plug a 1 into each of these x's. I'm going to have 1 equals, 1 minus 1 is 0, so all this goes away. 1 minus 2 is negative 1. So I have negative 1b equals 1, and so b must be negative 1. If I set x equal to 2, 2 minus 2 is 0, all this goes away. 2 minus 1 is 1, 1 times a equals 2. And so I'm all set then. I've got 2 over x minus 2 plus negative 1 over x minus 1. And yes, you could turn this into that. I often don't, because in the more complicated problems, like if you had a bx plus c up here, a lot of people do this thing and then don't change the sign on the next bit, and yeah, it just doesn't end well. So I'm going to leave it like that. All right, number 5. 5 says 2x plus 1 over x squared minus 5x plus 6. So we've got 2x plus 1 over x minus 2, x minus 3. Okay. That's, again, case 1. X minus 2 b over x minus 3. So let's multiply everywhere by our least common denominator. That's x minus 2, x minus 3, x minus 2, x minus 3, x minus 2 times x minus 3. So we're going to have a lot of canceling to do here. Boink, 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 and boink. And what's left then is 2x plus 1 equal sign a. This is left over. A plus, a b, and an x minus 2. Okay, yeah, I'm still in favor of magic numbers. I see two constants, I see two magic numbers. Woohoo! X equals 3. All this disappears. 3 minus 2 is 1 times b. And over here, 3 times 2 is 6, plus 1 is 7. If I make x equal to 2, 2 minus 2 is 0. All this goes away. 2 minus 3 is negative 1a. And over here, 2 times 2 is 4, plus 1 is 5. So we know a is negative 5. And so my answer will be negative 5 over x minus 2 plus 7 over x minus 3. Okay. Number 6. Take a look at number 6. Number 6 says 5x plus 1 over x minus 2 squared. Well, there's a case too where we have that repeated linear factor. And we have to allow for the possibility of both of these showing up. We just don't know what's in there. White flour, enriched white flour. I don't know how much of each of those are in there, or if one of them maybe isn't in there. That's why I'm going through this process of multiplying everything by the least common denominator, which is, again, not this times this. Please, don't do that. This right here is the least common denominator. So what about our canceling? Well, this cancels this takes one of those, this takes both of those. And now we've got something that's pretty tidy. 5x plus 1 equals a, x minus 2 plus b. Here I only have one magic number. I could use a magic number and a not so magic number. I actually think I'm going to use systems here. Ax minus 2a plus b. And I'm going to group the x stuff together. And when I divide by x, I find out that a is 5. And then I'm going to take the I don't have an x stuff and make them equal to each other. Conveniently, we know what a is now. And so I get 1 equals negative 10 plus b, or b equals 11. And so my final answer would be 5 over x minus 2 plus 11 over x minus 2 squared. Nice, nice, nice. 7. 7 says 2x plus 5, x plus 4 squared. That's going to be a over x plus 4 plus b over x plus 4 squared. Remember, if this were a 3, I would not only have these, but then I'd have a plus c over x plus 4 to the third. But for us, it's just x plus 4 squared, x plus 4 squared, x plus 4 squared. And then the canceling. This takes one of those, both of those cancel. And so now we're left with 2x plus 5 equals a, x plus 4 plus b. And again, I've only got the one magic number, negative 4, to work with. I think I'm just going to use systems here again. It didn't take so long last time. X plus 4a plus b. I'll group the x stuff together. When we divide both sides by x, we have a equals 2. If I take the not x stuff and set that equal to each other, and plug my value of a in there, I get that b is negative 3. So my final answer would be 2 over x plus 4 plus a negative 3 over x plus 4 squared. Of course, again, you could do that, and that would be fine. But to cut down on mistakes, I'm just going to leave that be the positive and put the sign up there. Fabulous. Okay, well, I hope you're feeling comfortable with this. Or if you're not, I hope you're already messaging GroupMe or going back and watching those last two videos about partial fraction decomposition. 8. We've got x squared minus 2x plus 3 over x minus 1 times x plus 2 squared. Ooh, 3 constants to find. Yeah, no, really, because look, this one, and then to the first degree, and then to the second degree. And so I've got a bunch of places to write my common denominator. I'm going to have x minus 1 times x plus 2 squared, x minus 1, x plus 2 squared, x minus 1, x plus 2 squared, x minus 1, x plus 2 squared. So when I'm done with all my canceling, I end up with x squared minus 2x plus 3. Here these cancel, leaving me a x plus 2 squared, plus this cancels one of those, b x minus 1, x plus 2, plus c. And then these cancel these, and we just have the x minus 1. So I see that 1 is a magic number. I see that negative 2 is a magic number. You know, you could do systems, but you got to foil and then group and, you know, case 4, I'm only using systems. But this combination of case 1 and case 2, no, I think I'm just going to use magic numbers. If x equals negative 2, this goes away, because negative 2 plus 2 is 0. 0 squared is 0. 0 times a, poof, gone, 0. And that happens here as well. So we just have to put our negative 2 in here and have negative 3c, and we have to plug our negative 2 in here. Negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. So 4 plus 3 is 8 plus 3, or 11. If I divide both sides by negative 3, I find out that c equals negative 11 thirds. Now, what about using the magic number x equals 1? Well, 1 minus 2 is negative 1. Negative 1 plus 3 is 2. This 1 will turn this into 0, will turn this into 0. 1 plus 2 is 3, and 3 squared is 9. So I have 9a here. Or a equals 2 ninths. Again, I think I want these to have a common denominator. So I'm going to multiply by 3 over 3 here. Negative 33 over 9 equals c. I've got an a value, and now I need a not-so-magic number. Again, 0 is a good choice. 2 is a good choice. Yeah, it's funny because I really want to do 2, but I think because these are going to go away, and these, I think I'm just going to go with 0 as my not-so-magic number. 0, 0, 3, 0. 2 squared is 4a, plus 0, 0, I'm going to get negative 2b. And if I plug a 0 in here, I have negative c. So let's plug in our a value and our c value and solve for b. Oh, and since these are ninths, I'm going to turn that into 27 ninths. Okay, so that's a 3, right? Is it a 3? Yes, because I plugged in a 0. So 27 ninths equals 4 times 2 is 8 ninths, minus 2b, minus a minus, plus 33 ninths. Okay, I add these together. That's going to give me 41 ninths. And if I subtract 41/9 from both sides, I'm going to have negative 14/9 equals negative 2b. And when I divide both sides by negative 2, that cancels there, leaving me a 2. Negative divided by negative, those cancel as well. And so I just end up with b equals 2/9. Don't forget to go back to the original problem and put in your things. If you want to turn that back into negative 11/3, that's certainly fine with me. I just find it's easier to solve for the other constants if everyone has the same common denominator. So, oh, and conveniently, I've gotten rid of what my a was. Oh well. I'm moving on. You can always go back and see what I said a was before I so aggressively erased it. So 4x plus 3 over 2x plus 3 x minus 1 squared. So that's a over 2x plus 3 plus b over x minus 1 plus c over x minus 1 squared. I multiply everywhere by the least common denominator. And for us, that's going to be 2x plus 3 times x minus 1 squared. 2x plus 3 times x minus 1 squared. 2x plus 3 x minus 1 squared. And 2x plus 3 x minus 1 squared. What cancels? Well, all of this cancels that stuff. This cancels here, and this takes one of those away, and this takes both of those away. And so we're left then with 4x plus 3 equals a, x minus 1 squared, plus b, 2x plus 3 times x minus 1, plus c times 2x plus 3. Again, like the last problem, I've got these two magic numbers, 1 and negative 3/2. And, it worked pretty okay not to have to FOIL and distribute and then regroup and then solve that system. Ugh. Instead, I'm going to say x equals 1. 1 times 4 is 4, plus 3 is 7. 1 minus 1 is 0, so that goes away. 1 minus 1 is 0, so that goes away. And so 1 times 2 is 2, plus 3 is 5c, and so c equals 7/5. If I make x equal to negative 3/2, that's going to turn this into 0, right? Because 2 times this will be negative 3, plus 3, 0. This all goes away. This also goes away. So really, I'm just plugging in the negative 3/2 here. So what am I going to get? 4 times negative 3/2 plus 3. Well, there's some canceling. And that's going to be negative 6 plus 3 is negative 3 on the left side. And if I plug in negative 3/2 here, negative 3/2 minus 1 is the same as negative 3/2 minus 2/2. So I get negative 5/2 squared. Okay, so negative 5/2 squared a. And that's going to be 25/4 a, because I'm squaring top and bottom. Well, if I multiply both sides by the reciprocal, I end up with negative 12 over 25 equals a. And again, I'd like these to have a common denominator. I'm going to multiply top and bottom by 5 over 5. And so I'm going to have 35/25 equals c. And finally, I need a not so magic number. And you talked me into using 0 before. Yeah, maybe I should do 0 again. Maybe I should demonstrate the other one. I'm going to go with 2, because 2 minus 1 is 1. So x equals 2. That's 8 plus 3 is 11. And 2 minus 1 is 1. 1 squared is 1, so I just have a. 2 minus 1 is 1. 2 times 2 is 4, plus 3 is 7. 7 times 1 is 7b. And then here, 2 times 2 is 4, plus 3 is 7c. We know what A and C are, so let's plug them in. 11 equals negative 12 over 25 plus 7 times 35 over 25 plus 7b. Well, sadly, there's no canceling, but there can be combining like terms. So that's 210, 245. 245 minus 12 is 233 over 25 plus 7b equals 11. So, I think I could multiply top and bottom back here by 25 over 25, but I kind of feel like I just want to get rid of the fraction. So I'm going to multiply because this is an equation with fractions, and we saw in the Algebra Basics unit that if we just multiply everywhere by the common denominator, we can get rid of the fractions. That's 250 plus 25 is 275 equals 233 plus 7b. 275. If I subtract, I get 42 equals 7b. And so b equals exactly 6. That is so unexpected. Oh. No, you don't, Mr. Kukla. Yeah, so here's good. That's 42, but remember, there's also a 25. So 42 equals 7b times 25. And that's kind of important because I'm going to divide and get that 6. But I still have to divide by 25. So b doesn't equal 6, but instead b equals 6 over 25. Okay, so I've got my b, my A, and my C ready to plug in there. And let's see if I can do that. Negative 12 over 25, 2x plus 3, plus our b value, 6 over 25, and that's going to be x minus 1, plus our c value, 35 over 25 over x minus 1 squared. And for a long time, I've complained about, why does the textbook insist on writing this other way? This is fine, and if you stop here, I'll give you full credit. But on the textbook, we see things like this. Where they moved all these 25s to the bottom so that we didn't have complex fractions. And I actually kind of like that a lot better. There's my answer. I wouldn't mark that wrong. Number 10. Let's take a look at number 10. 10 says x minus 3 over x plus 2, x plus 1 squared. And that's going to be a over x plus 2 plus b over x plus 1 and c over x plus 1 squared. I bet you know what I'm going to do next. So here we go, x plus 2, x plus 1 squared. X plus 2, x plus 1 squared. X plus 2, x plus 1 squared, and x plus 2, x plus 1 squared. And now a whole lot of canceling. Here, we've got x minus 3. This one takes this one, leaving me the a and the x plus 1 squared. Got a plus sign. I've got a b. This takes one of those. We still have an x plus 2 and this x plus 1. Now we've got another plus sign, a c. These cancel these, and an x plus 2. And I think I'm about to say I don't want to do that foiling, and instead I'm going to use x equals negative 1. Why? Because this turns into 0, and this turns into 0, and so negative 1 minus 3 is negative 4, and negative 1 plus 2 is 1, c. And I'm done with c. And when x equals negative 2, well, negative 2 plus 2 is 0, so this goes away. And here, negative 2 plus 2 is 0, so all this goes away. Negative 2 plus 1 is negative 1, and negative 1 squared is 1. 1 times a, I'm plugging a negative 2 in here, and I'm getting negative 2 minus 3, or negative 5. So I've used my two magic numbers, and now I need to put in a not-so-magic number. I'm going to use x equals 0, so I'll have negative 3 equals 1a, 0, 0, that's plus 2b, and 0 plus 2c. So luckily we know our a and c values, and we can plug those in now. Negative 3 equals negative 5 plus 2b plus 2 times negative 4. Or negative 3 equals negative 5 minus 8 plus 2b. It's going to be negative 3 equals negative 13 plus 2b. And when we add 13 to both sides, we're going to get 10 equals 2b, and so b equals 5. Nice. So my final answer then is going to be negative 5 over x plus 2, plus 5 over x plus 1, and then plus negative 4 over x plus 1 squared. Ta-da! Done and done. Okay, last two problems. Case 3. That's kind of exciting. I'm not sure that I put any case 3 on any assessments we're going to see, but I do think for those of you going on to calculus, this is a good thing for you to experience. X squared plus 1, x minus 2. Okay, so remember with this irreducible quadratic, i.e. I can't factor this with real numbers, I need ax plus b on top of x squared plus 1. And then I need a c over the x minus 2. Remember, if this problem had been x squared minus 1 times x minus 2, I wouldn't need to do that, because this factors as x minus 1, x plus 1, x minus 2, and so my setup here would be a over x minus 1, b over x plus 1, and c over x minus 2. This is not irreducible quadratic. I can, in fact, reduce that to these linear factors. It's only here where I can't factor this unless I use imaginary numbers, which I'm not going to use. Yeah, that's why this is irreducible, and I've got to have that thing on top. So I'm going to multiply everywhere by my least common denominator, which again is, oh, it is this times this. How rare and convenient. X squared plus 1, x minus 2, and x squared plus 1, x minus 2. I will say, with these problems, I think you're going to be much happier if you do that. Because what often happens is people only distribute the b to these things, and not all of this. Okay, so what cancels? That with that, that with that, that with that. And so what's left over is this 3x. I've got that ax plus b times that x minus 2. And over here, we have c times x squared plus 1. All right, I got 3 constants to find, and I've only got 2 magic numbers, 2 and 0. I'm going to try systems. I may regret this. 3x equals ax squared plus bx minus 2ax minus 2b plus cx squared plus c. Okay, so I'm going to group the stuff that has an x together. And divide everywhere by x, so 3 equals b minus 2a. Okay, and then I'm going to take the stuff that doesn't, oh no, look. Oh, yeah, no, I really don't want to do this. I would really rather go back and plug in the 2 and the 0 and do magic numbers. But because I've started this, I'm going to finish it off. These things without x's, yeah, I don't have any of them over here. So that's why I'm writing a 0. Minus 2b plus c. And so I guess we could say that 2b equals c. And then finally, the x to the second stuff. X to the second, x to the second. And again, there's no x to the second stuff over here. So I'm going to have 0 equals ax squared plus cx squared. And if I divide everywhere by x squared, I get 0 equals a plus c. Okay. Well, I know that c is equal to 2b, so I can put this over here, and now have 0 equals a plus 2b. And look, two equations with a and b in them. Oh, how convenient. 0 equals 2b plus a. Okay, so now I'm going to use elimination. And remember, when we use elimination, we want the coefficients either to be the same or opposites. It doesn't matter whether these are the same or opposite, or these are the same or opposite. I think I'm going to go with these being the same. So that means I need to multiply by 2, and by 2. So I'm going to have 6 equals 2b minus 4a over 0 equals 2b plus a. And because I'm doing elimination, I'm subtracting. So I'm going to have 6 equal to 2b minus 2b, those cancel. Minus 4a minus 1 more a is minus 5a. And if I divide both sides by negative 5, I get my a value. Now that I know my a value, I can take this a value here and plug it into this equation to solve for b. And then once I have that a and that b, I have lots of choices. But I would probably plug my b in here to solve for c. Yeah, no, I'm not going to do that. I mean, I should do that. You need to do that. But no, I'm not going to do that. I will, however, do that last problem, number 12, which is 1 over x squared plus 3 and x plus 1. So that's ax plus b over x squared plus 3 plus c over x plus 1. I'll multiply everywhere by my least common denominator. X squared plus 3, x plus 1. X squared plus 3, x plus 1, and x squared plus 3, x plus 1. And then I'm going to cancel. 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 Remember, it's a really good idea to keep that in parentheses because you've got to FOIL it with this. And this cancels that, leaving me c, x squared plus 3. Okay, yeah, I did systems last time, almost completely to the end when I whimpered and gave up. So now I think I'm going to go with magic numbers. If I plug in a -1, -1 plus 1 is 0. 0 times this stuff all goes away. So 1 equals -1 times -1 is 1. 1 plus 3 is 4c. So c is 1/4. Now, what about x equals 0? That's a magic number. Okay, so that's going to go away. And that's just going to be a 1. So I'm going to have 1 times b. And then here, 0 plus 3 times c is 3c equals 1. Well, luckily we know what c is. So 1 equals b plus 3 times 1/4, 3/4. And if I subtract 3/4 from 4/4, I get b is also 1/4. Okay, now I need a not so magic number. Yeah, I don't want to use, no. Yeah, I'm just going to pick 1. X equals 1. So I'm going to have 1 equals a plus b times 1 plus 1 is 2. So 2a plus 2b plus 1 squared is 1 plus 3 is 4c. Luckily, I know b and c. So 1 equals 2a plus 2 times 1/4 plus 4 times 1/4. So what happens? I get 1 equals 2a plus 1/2 plus 1. Well, that's going to be 3/2. And when I subtract 3/2 from 2/2, that -1/2 equals 2a. And so I get that a equals negative 1/4. Oh, I like that so much better than the last one. So now I've got to plug these values in. And I'm going to use this strip here. I'm going to have a negative 1/4 x plus b over x squared plus 3 plus c over, which is 1/4, over rx plus, I seem to have obliterated it, it's x plus 1. And again, I think I kind of agree with our textbook. This looks nasty. I can factor out a negative 1/4 here. And then I'd probably even write it this way. X minus 1 over 4 x squared plus 3. Look, and just because I'm a tidy freak, it doesn't mean you have to stop here or do that. I mean, yeah, you don't have to follow me down this path, but I think that's tidier. Plus 1 over 4 x plus 1. Okay, there we are. We're at the end. I hope this was a helpful review for you to check your work, and I look forward to talking to you soon. Take care, everyone.